All right, hello everyone. Welcome. Nice holiday weekend. Hope you're staying warm out there. It's getting pretty chilly. I just wanted to remind you something that's going to be coming up later on this week in just class. We're going to have our first day class on Thursday of this week. So as I mentioned last week, attendance is required on those days. There will be a sign-in sheet that I'll be bringing around in class on Thursday to take attendance. You will work on the assignment while you're here in class and then submit it at the end of class. The TAs, at least one of the TAs will be here to help out as well, so you get a chance to meet them. The first in class assignment is pretty easy. It's pretty chill. It's not going to be a super hard one. There'll be plenty of time for you to get it done in class. They will be simple though. It won't all be. They'll definitely get a little trickier as time goes on. But this first one, really pretty low pressure. Nothing to get too concerned about. For this one, should be pretty straightforward. Just want to make sure that you all are aware that your attendance is expected on Thursday. You are able to drop one. So if you get sick or you have some other conflicts, you can drop one. Hopefully you don't have to drop the first one, but you don't get to control when you get sick. So stuff happens. I understand that. I think that's all I had in terms of logistical announcements. Any questions on the course calendar or anything before I hop into talk about some command line stuff for today? Awesome. So there was a little bit of stuff that I did not get to at the end of last class that I want to start off with before we hop into the new material that I had planned out for today. But hopefully you brought your laptops. Hopefully you've got your command line up and running. The first thing that I actually want to do is give you a little tour of the file system. So one thing that I think is useful to know is that at least on Unix-based file systems, which includes Macs, by the way, does not include Windows machines. So we kind of have a hybrid system going on here for us Windows users, where it's kind of Windows, kind of Linux based. For any machines that are in that format, the file system is set up in a pretty standard way. There are some variations, right? So everything that I'm about to show you might look a little bit different on your computer than what it does on mine. And if you ever access other computers, a little bit different on those computers than what you see. But it's good to know what the general file structure of a system is and kind of be aware of some of the major parts. And as you move along, you'll get to learn more and more about those different parts. But I'm just going to give you a quick tour today before we hop in and learn some new commands. The first thing that I'm going to do today is cd into slash. Name for this. R rhymes with boot. Yeah, that's going to be our root. So the way to think of the root, that is the beginning of the file system. Or another way to think about the roots, based on what we talked about last week, right? If I'm in the root directory, if I'm in the root of the file system, and I try to do cd dot dot, it's not going to work. There's no other folders for me to go back to, right? This is the beginning. This is the origin. So another way of thinking about the root is that all files on the computer I can get to from here. Every single file on the computer I can get to from here. It's contained in a folder, perhaps, but I can get to from there. And so this is where a lot of the standard stuff is going to be on your Linux-based file system. So if I type ls, this is pretty much what I expect to see on any computer that I interact with in its root directories. Again, some exceptions. Some computers might do things slightly differently. They might not have one or two of these, or they might include some extra ones that aren't on my list. So if yours looks a little bit different than mine, that's not going to surprise me too much. But I would expect to see at least some of the same things on yours. I actually already showed you one of these at the end of last class, but it's an important one, so I want to show it to you again. The bin directory is short for binary, and that binary directory quite literally contains all of the commands that we've talked about so far, plus a bajillion other ones that we haven't talked about. Talk time over every single band on the computer. There's not enough hours in the client to do stuff like that. But the bin is short for binaries. Anytime you see a directory called bin, your brain should hopefully think binary. These are binary files. These are programs. These files aren't for me to look at. These files are for the computer to look at. Binary files are for the computer to use. That's what the computer likes to do, right? But that's not the only folder that's worth knowing about in the root directory. Another important one to know about is the user directory over here. So if I cd into the user directory and take a look at what's there, oh, I actually see, hang on a second, this was actually a little bit different. I'm sorry, I picked the wrong that's not the directory I meant to tell you about. That's why I was confused. I meant to go into the home directory. My apologies. I misspoke. The home directory, if I look at what's in here, I see, oh, there's one folder with my username on it. And you probably see at least one folder or username on it in the home directory. This is quite literally what it sounds like. This is where my files, it's where my folder, my home folder is on the file system for your personal laptop, the computer that probably only you use. This isn't going to ever be terribly exciting, right? But if you're ever on a system that lots of people are using, which is actually something that's going to happen today, I'll actually see that today, a little bit later on, then I would expect to see one directory in here for every single person that is using that. Right? Every single person that accesses a computer is going to have their own home folder with their own stuff in it, their own things. So not too exciting on a single person laptop, but on a machine that lots of people are using, there's going to be lots of stuff here, lots of folders. Later on, we can take a look at one of the WashU servers and see just how many home directories are going to be present on there. Some other ones that are good to be aware of in the root directory. MNT is short for mount. So that's going to be where anytime I add more disk space to a computer, get added here on the mouse. So another way of thinking about that is if I have like a flash drive, and I plug it in, where are those files going to show up? They're going to show up here. They're going to be mounted in the mounter, right? So if you go into that directory right now, if you're on a Mac, I wouldn't actually expect to see much of anything. Maybe there's something in there if you have something plugged in. On a Windows machine, if you are using Windows System for Linux like I am, you can actually see that the C drive is mounted here. That's how I access all of my Windows files from my Linux. Macs can access those files directly, so they don't need to jump through any extra hoops like us Windows users do. So I wouldn't expect to see too much stuff in there for a Mac user. But as I said, anytime you plug another piece of data into a USB, for example, that's where it would show up. And then some other things to be aware of in, like, for example, the etc. directory. This is filled with tons of stuff that is really more for the operating system to be considered. So there might be times that you would have a reason to go in here, but this is certainly a be very careful, know exactly what you're doing kind of place, right? Not something that I would just go in and willy-nilly start changing stuff at random. These are files that the operating system needs to do operating systems. And so it's not unheard of to have to go in here and change some configuration settings or something like that. But like I said, it's important to kind of have an idea of what you're doing before you poke around with these files. Be very careful. Actually, most of the rest of the directories in here kind of fall in that category, like the boot directory. Oh, it's empty right now, but is used for when the computer's booting up. If there's any special files that it needs to boot up properly, that's what that directory is for. So yeah, I'm not going to go through all of them. Some of these, are somewhat self-explanatory. TMP is for temp. This is more system files over here. SRV is for server. So my laptop is not. I'm not hosting any websites on my computer. But if I was, then I might be using the search to show that, hey, these are where the pages are for my website that I want you to search. Come visit my website. So all of these do have a distinct purpose. They're not all relevant to us, but I do think it's worth knowing that this is a typical structure. I know Apple computers like to add in their own stuff in there, right? So you might see some additional Apple kinds of things in there if you have a Mac. Other computers will do things differently. So there are variations on this, but by and large, this is a pretty standard setup for a file system. And any file that you can conceive of on your computer, I should be able to get to from here. So yeah, I'm actually going to restart my. Oops, I don't know what happened there. I'm actually going to restart my terminal to get back to where I used to be, so that I can move on to the next thing that I want to talk about. That was just a little side detour. The next thing I actually want to talk about, I touched on this very briefly at the end of last class, but I want to make sure to go into it in a little bit more detail. If I run the ls command with -l, I did show this to you last Thursday. It shows me things such as the time and how big the file is. I actually want to focus on this stuff over here on the very, very left-hand side, though. The first letter that I see, if it's a D, that's for a directory. So if I see it marked with D, that tells me that that's a directory. If I see an N, the very first letter, that tells me that it's a link. The full official name for that would be a symbolic link. I'm actually not going to talk about that a whole lot in this class, but you can think of it as like a shortcut on a Windows machine. It's the same kind of idea. It's like a link for me to get to a file that lives somewhere else on the computer. I'm not going to be using those a whole lot. Anything that does D or anything else, it's just a plain dash, those are just files. So any file, right? It could be a text file, music file, Excel file, document, whatever it may be. Those will just have dashes here, kind of directories or links, plain old regular files. That's actually not what I really want to talk about. I'm talking about all this gibberishy looking stuff that comes after. So everything after that first letter is what's known as the permissions, the file permissions. And those dictate who can do what to a particular file. There's actually 3 groups of permissions given you. So the first 3 letters form the first group of permissions, second 3 letters form the second group of permissions, and the last 3 letters form the third group of permissions. Those are permissions for different categories of people, different categories of users. So the first permissions apply to the owner of the file. If you're using your own personal laptop, chances are the owner of the file is you. There aren't many other people using your computer, so you probably own all of the files. That means that these permissions are typically very open. Right? I want to be able to do whatever I want with my stuff. And that's what this is saying here. It's saying that the owner has R for read permissions. That means I can look at the file. W for write permissions. That means I can change the contents of the file if I want to. And X for execute permissions, which means that I can run the file like a program. I can run it as an executable. And that's pretty common for the owner category to have full permissions. It's pretty typical. Like I said, we want to be able to read and write for our own stuff. The next permissions are the ones that usually require the most fiddling with. So the middle category permissions applies to the groups. Now, actually, groups aren't used, again, a whole lot on your own personal laptop. But if I'm on a machine that has lots and lots of users on it, then I probably have like an administrators group, for example. I have a users group, for example. I might have lots of different types of people who are using that machine. And that's what these permissions apply to. The third category of permissions is everybody else. Anyone who is not me, the owner, and anyone who is not in my group, whatever group that may be. This is some rando, right? Some random person manages to CD their way into this directory and look at the files. What should they be able to do? And again, on your personal laptop, it doesn't matter, right? Nobody's using my computer except for me, not that I'm aware of anyway. So, having these be very open, allowing anyone to read, write, execute, not going to be a problem. But again, put yourself in a situation where I am on a public server, right? That lots and lots and lots and lots of people can use. I definitely want to restrict what some random person can do to my file. So I want to be able to, for example, allow people to read a file but not change it by turning the write permissions off. And the way that we do that is using the chmod command. So the chmod command is a very common one. The way that it works is we type chmod. That's an indication that we want to change the permissions of a given file. After we type chmod, we have to type in three numbers between 0 and 8. In practice, there's only a few configurations that I ever practically use. Typing in 7 for the first number, that refers to this first group of 3 permissions. So we can think of each of these as a binary value where R counts as 4, W counts as 2, X counts as 1. So by saying 7 here, I'm saying that the owner, me, should have all 3 of those. 4 plus 2 plus 1 is 7. I'm setting all 3 of those to be active. I should be able to read, write, and execute. It's the last 2 that usually need the most fiddling with, the most modification. For example, a lot of times I want people to be able to read but not write. So that would mean if read counts as 4, then I could just say 4. It would be only the R, no W with no X. Or sometimes you want them to be able to read and execute. That would be 5. 4 plus 1 is 5. So the 2 most common values that I use with the ch command, again, you can use any combination of values you want, but the 2 most common ones that I use are 755 or 744. And the reason why those 2 are the most common is because that 7 means that I still get to do whatever I want with the file. I have all of the permissions. The 44 or 55, depending on what your use case is, means that nobody else can do anything except for read. And if you really want to be restrictive, I suppose you can make a case for 00, right? Then it's top secret. Then nobody can even look at that file, right? They can't even look at it. But in order to actually run this, we need to, pick a file. I have one here called test.txt. So this should, if it works, I'll be honest with you, I'm a little bit hesitant about this part, but ideally, if it works, this would change to show that I still have read, write, next. All of these, the group and for everything else, would go away if this command works the way that it does properly. If it doesn't, I'll talk a little bit more about that, but let's try it and see. Yeah, okay, so it didn't work. I would expect this to have changed, but let me explain to you why it didn't work. It again has to do with I am on a Windows machine. These files are being managed in different ways with the Windows permissions, now also with these permissions. So in that case, there's a conflict between those permissions sometimes, where the Windows permissions win out over what I'm trying to say. In some senses, I'm not too concerned about that because, again, I'm not changing the permissions of files on my own machine very often at all. It's my computer, it's my stuff, right? The only way somebody could access it is if they stole my computer or physically had access to my computer. I am doing this more often when I'm connected to a different computer that is not my computer. It's accessible by lots and lots of different people, which yes, is something we're going to do today. So I might actually try this example again once we're in a more reasonable place to use this particular command. Okay. I think that's all of the leftover stuff from last time. So let's go ahead and move into some new stuff. We're going to talk a lot about files today, actually, and how to use files with the commands that I've shown you so far. I'm also going to introduce some new commands as well. some very powerful commands as well for today. For starters, let me show you a quick and easy little command. Let's say I want to make a new file via the command line. This is a nice, simple one. We can use the touch command. So if I type touch and then file.txt, that will make a new file for me called file.txt. And so if I run this particular command and run ls, you can see that I now have access to that file, and that's nice. That's good. I want to talk a little bit more about how to use files with commands, however. So one thing that I might like to do is take the output of a command and save it in a file. That actually has a lot of nice uses for us, it turns out. So the way that we do that is by using something called redirection. So for example, if I wanted to take the output of ls, I mean, of course I can type ls in and see all the list of all the files, but let's say I wanted to take that list and actually save it to a file. Some of you might be thinking, well, just copy and paste it, you know? Okay, yes, I suppose that would also work, but I would argue that it is faster and simpler to do something like this. This is what's known as a redirection. It says, take the output of ls and store that output into this file. The direction of this arrow, does matter very much. We will talk about what it means when the arrow is pointing the opposite direction a little bit later. Now, the file does have to be on the right-hand side, and the command absolutely has to be on the left-hand side. You can't flip it. It won't like that. So let's try it. Let's take a look and see, okay, this time it didn't print out anything. Right? That's because I quite literally redirected it. Instead of printing it out on the command line, where it used to, I redirected it into the file. How do I know? How do I know that it's actually in the file? Well, you could, of course, open up your file explorer and go find that file and open it up. Or if you want to use the command line to do it, let's talk about another command. There's a command called cat. Cat is a command that lets us view the contents of any file that we want. So if I type cat file.txt, now it's showing me the contents of that, and it looks like the output of ls. It's like the output of ls. Let's take this a step farther. Let's say I wanted to, add a little note to this file. At the end of it, maybe I'll say something like, this is the output of ls. If I run this command by itself, it's just going to print it, right? It'll just print it. So that's not very useful, but if I do redirection into file.txt, right? Now it's not just going to print it on the console, it should put it in the file. Let's try it and see. I'll do cat file.txt, and whoops, I made a mistake. I made a mistake on purpose. I knew this was going to happen. I wanted to illustrate that when you use redirection like this, it is actually going to overwrite anything that was in that file and replace it with the new stuff. So you're probably thinking, well, that doesn't sound particularly useful. Is there a way that I can not do that? The answer is yes. Actually, there's two forms of redirection. So the proper way to do this would be to, let's first redirect the output of ls into a file, just like we did before. And instead of using this statement, again, I use the up arrows to find this instead of having to type it all out again. That's a nice little shortcut. By using two arrows. This now says don't erase the stuff that's in here, just append it. Append it onto the end of the file. So this will keep what is already in the file and append my new message onto the end of that file, and you can see that it did exactly that. Some people hear that and think, okay, I will never use a single arrow. I will always use double arrow. Okay, I don't think that's an unreasonable idea. I think that is fairly reasonable. There might be times when you do want to erase the contents of the file, so it's good to know that that single arrow option exists. But if you want to use the append option just to be safe and make sure you don't accidentally erase contents of a file and you don't need to, I don't have any problem with that at all. That's perfectly okay. In fact, I probably feel pretty similar. I use the double arrow quite a bit for that exact reason. Now, that's only one direction. We can redirect things the other way as well. So when we use redirection going from left to right, that is taking the output of a command and putting it into a file. When we do redirection from right to left, that is the action of taking the contents of a file and feeding it into a command. So let me show you an example of that. There is a command called sort, and it does exactly what you think it's going to do. It sorts the contents. It doesn't have to be a file. It'll sort anything that you want, but it sorts it in alphabetical order, line by line. Sorts it in alphabetical order. If I wanted to use a file as the input to be sorted, then I would use redirection for that. So I would say something like this. Take the contents of file.txt and add it to the sort. Note again that the direction does absolutely matter here, right? The file is always going to be on the right-hand side, and the command is always going to be on the left-hand side. So the direction of the arrow tells me which way the data is flowing. If it's pointing to the left, it's coming out of the file into the command. If it's pointing to the right, it's coming out of the command and being stored into the file. But if you run this, it'll happily feed the contents of that file into the sort command and print everything out in sorted order, just as you would hopefully expect. Also, too, notice that it's important, I think, to point out that while there is a double arrow going to the right, this is not a thing. Double arrow going to the left, not a thing. We're not putting things into a file, so it's not something we have to worry about, right? Left arrow is going always going into a command. So we don't have to worry about accidentally overriding any of those contents. The file itself, when using the left-hand redirection, is unchanged. I'm not changing the contents of that file at all. I'm just grabbing the info out and feeding it into a command. Any questions I can cover before I turn you loose on the first exercise of the day? Yes.
What does it mean? Sort. Is it sorted by or
Yes.
sort by like
It's sorting by alphabetical order, and if numbers are involved, it will also sort. Although you'll notice that by alphabetical order, it sorts caps first and then lowercase afterwards. So you can see it sorts all of the capital letters, and then it restarts with the lowercase letters and sorts them alphabetically as well afterwards. If there were numbers involved, those would also be sorted. I think those would appear before the capital. I don't remember actually if they would appear before the capital letters or if they would appear at the end, but it will also sort things numerically.
so there's something if we use like the if we take out the information from the byte, like not all things are like yeah.
I would agree with that. So the question is, not all commands are valid. I mean, not all commands take in additional information, right? So like the ls command, I think actually you can type in like a directory or something after ls if you wanted to, but most of the time I just use ls by itself. So what is there to even feed into that, right? I'm just using the command directly. pwd might be a similar one, right? Like it doesn't require any information to run. It's just the command. That's just what it does. So using redirection with pwd is probably not something that I would expect to happen. It's just not a useful command for that. But other commands, like the sort command, are very much will be useful for that. And we're going to take a look at one actually after this exercise too. That'll be very useful for that purpose as well. Great question. Any other questions before I turn you loose on doing a practice problem? All right. Give me a second to pull it up here. Exercise number 1 for the day. I want you to talk to your neighbors, get their names, and put them in a file called names. Now, please use the command line to do this. We're talking about redirection. I know you can open Notepad and type stuff into Notepad. That's not what we're talking about, though, right? Use redirection to do this. Use redirection to manipulate the file and put the correct information into a file. Then I want you to print out those names in sorted order. And as a little bonus, see if you can figure out how to sort stuff in reverse order. I haven't told you how to do that, so you're going to have to do a little bit of digging. Probably not too much digging. It's not super difficult, but just a little reminder of how to look up information when you need to. I'll give you, I don't know, 5-ish or so minutes to work on this, and I'll be around if you need any help. Go back. Excuse me. Yeah. Yeah. You push me. Why is it so your problem? I'm saying, and you're you person, so that would be like, so. Well, that would connect. Putting all page back. Question like you took one song and then go work out here again. But that is so I didn't think do great. Poorly. ours. Let's go back to one. So you're on one of the things in my say. Awesome. Yeah, I've heard of that. But yeah, I don't know if you that's how skins. What's your name? There's CD and some. Oh, no. It's try some fast. You can just hold on right and see. I didn't want to see. Right now, now I've heard. Doubles. Oh yeah, alrighty. Wait, okay. No, that's well sorted. This is true. I gotta go. just your name. Oh, it's like real West. That's how you would go to Google and do it all in one shot. I don't get it. That and then like new line dash and stay here. Yeah. Oh, no. Not using it, I like that. See, we can look up and this morning. How do you Oh, you can look up, so we set to index thing with math, so that index first find it, if I go down, it's like, with the flag, as far as, five. So I see if you're gonna it's, so you go, also, backspace. Bro, there's this really like adjectives that's in itself. Like, now, let me take exactly got this. You have a question? Yeah, like how they like so long. Probably once. I literally like this box. I think you need 5 minutes. It's like, yeah, sorry. But yeah. Oh. It was, yeah. Well, you're on a Mac, and you are dedicated, like you're just on need to be honest. Not exactly. But what do you for trying? I mean, that's all you do. Try and see what happens. All right, everybody. Heard lots of great conversations, got lots of great questions about this one. I want to run through it real quick before we move on to our next one. In fact, I want to show you another little shortcut, another little trick you can take. A lot of people, I think, probably started by, using the touch command, which is fine. I showed you that command for a reason. It certainly is useful. But a little shortcut is to actually realize that if I do something like this, and the file that I'm redirecting into doesn't exist, created for me. So I don't actually need to take that explicit step of creating the file if I don't want to. I can let the redirect create the file for me if I want to. That's totally fine as well. I can prove that to you by, showing you that that command runs, and then when I cat names it, there's my name. It worked, right? Another thing that I think is interesting to point out. This file is names. It's not names.txt or names.docx or anything like that. The command line doesn't care. The command line does not care about the extension. That's what that's called, the file extension, the .txt, .docx for a Word file, .xlsx for an Excel file, right? Command line doesn't care. Command line treats all files the same way. If it's got an extension on there, okay. If it doesn't have an extension on there, also okay, right? The commands are going to do what the commands are going to do, regardless. Those extensions are more for your operating system. The extensions exist so that when I click on a .xls file, it knows that I need to open that in Excel. But I'm not using Excel on the command line, right? So the command line does not care. Those extensions are not required, and a lot of commands will work perfectly well without them. So, yes. Yeah, that's a great question. So the question was, does the cat command work on different types of files? And the answer is yes, absolutely. The cat command will work on whatever file you tell it to look at. Now, there is one exception. If I try to cat a directory, it'll tell me, that's a directory, right? I can't show you that. But what about something that is not actually text? Because PDFs do contain text, but they aren't all text. There's lots of other stuff in there as well. Actually, if I go back to bin, let's look at the bash file, right? This is quite literally the command line program, right? If I take a look at this with cat, it'll show it to me, but oh my gosh, I can't read it, right? This isn't intended for me to be read. Again, it's in the bin directory. This means it is binary, quite literally zeros and ones intended to be interpreted by the computer. It's not meant for humans to be able to read, but cat doesn't care. Cat does not care whether I'm supposed to be able to read this file or not. Cat's just going to dump the contents of that file. You can see that a lot of it's just question marks because it doesn't even know how to properly display those characters because they're not letters or numbers or anything. They're bytes, right? So the actual command line is going to do what you tell it to, and it's up to you to know whether that's actually a good idea or not. Sometimes it's not. So yeah, great question. Let me get back to my home directory real quick. Oops. Let's see, I'm in Mount C users. Okay, here we are. Great. So then I had some other people ask me, how do I type in all the names in one command? Because the exercise was certainly intended for you to run the echo command multiple times, one for each name. So, I would put in my daughter's name to the names file, and then I would put in my son's name to the names file, right? This was the intention. Some people ask me, multiple people ask me, how do I do it all in one shot? What if I get all the names and I just want to write the echo command once and put all the names in there? There has been mixed success with stuff like this, where we type in the first name and then /n is what's called an escape character. It stands for new line, right? Some terminals will recognize that escape character, but I also talked to at least one person whose terminal did not recognize that escape character. Again, not all of them are exactly the same. The Windows versus Mac might have something to do with it, as I suspect that it did in this case. Sometimes it's not that at all. Sometimes it's something else. So, there are slight variations. But just to make it clear, the intention of this exercise was to run the echo command once for each name. That was kind of how I figured people would do it. I also made a mistake though with these last couple names. Should be a double arrow, right? If I look at the contents of the names file right now, it's only going to have Simon, because that was the last one that I did. Should have been double arrow for those last ones if I wanted to keep all of them. So now I have to, go back and do some of these over again, which is slightly annoying perhaps. There's the first one. All right, now I can cat my names file. There we go. And then the last part of this exercise was to get it sorted. So I kind of gave you this first one, right? To sort the names in alphabetical order, it would look like that. But then I asked, all right, how do we sort it in reverse order? Actually, I think my original file already is sorted in reverse order just by coincidence. But to ensure that that isn't the case, you of course could look it up on Google or ChatGPT if you wanted to, but the theme of this class is doing things via the command line as much as possible. So if I take a look at the man page, I see that there is a -r flag that I can use with the sort command that should get me what I'm looking for. So I can say sort -r and then do my redirection. I think this is good to know, right? I can still use flags with my commands even when I'm doing redirection. It's not going to get in the way of anything. It'll work just fine. It'll all work out just fine. Any questions about this exercise before we move on to the next topic on our to-do list for today? All right, fantastic. So I've showed you how to do two forms of redirection, right? Redirection always involves files, always. So when I say that word, redirection, I'm talking about either redirecting something into a file or redirecting something out of a file into a command. There is another very important concept, though, which allows us to chain commands together. We call this piping. We're going to pipe commands together. We quite literally are going to use the pipe to make that happen. But first, before we get there, I want to introduce a new command, which is a very, very important one, and one that you'll be expected to use on the upcoming in-class homework assignment on Thursday. It's a good one to know, called grep. I actually do not recall off the top of my head what grep is short for. I'm sure it's an acronym abbreviation for something. The man page might have more information, but grep is used to search files, search for things. So for example, if I want to search for my name in the names file, this is the command that I would use, and grep will show me all of the lines in which my name appears. So just to make things a little bit more interesting, I'm going to say echo, a message into the names file. Now my name shows up multiple times, right? Or it should. We can take a look. Yeah, it shows up twice. If I run the same command, notice that it not only finds both of the times my name shows up, but it's showing me the entire line. I think that's important to understand as well. Grep shows me the entire line where that search result was found. So it doesn't just show me the word that I'm searching for, but it shows me the entire line that contains whatever it is I'm searching for. So if my name appears on 5 different lines in this file, I would expect to see all 5 of those lines printed out when I run it through. This is a very, 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 very powerful command, especially when used with other commands. So let's say, for example, that I have a directory that has hundreds, thousands of files, just tons and tons and tons of files in it. So many files that, I type in ls and the list is so long and I'm looking at it, I'm like, I only need this one file. Do I really have to scroll all the way through this giant list just to see if the file that I'm looking for is there? No, actually, we can use grep. We can use grep to help us. This is, I think, one of the simplest and also fairly common uses of grep. I can use the ls command and grep together. And I can type them so that the output feeds from one command to another. So in order to do that, I would say something like ls pipe, and then start typing out my grep command. What file do I want to search for? I'll search for the names file, the file that we were just using in the previous exercise. I know that one exists. What is this going to do? This is going to take the output of ls and pipe it into the grep command. So that when I run this, it shows me that, hey, it did find a file called names. Well, wait a second. This becomes a lot more useful when I add the -l flag after ls, because remember, the -l flag shows me not just the names of the files, but also all of the properties and other information. So now my output looks something like this, where I see all of the permissions, who owns that file, the date and time that it was last modified, how big that file is. This is great. Now I can search for the information about a particular file in a directory without having to sort through the entire list of ls. ls, by the way, I love ls. It's great if there's, only a handful of files in a folder. That's just fine. But in cases where there's a big old pile of files and I don't want to have to search through all of them, this is a great technique to use. Piping is only used with command. So there's no This is a file, right? But there's no redirection happening. What we're actually doing here instead is piping the output of ls into the input of grep. So piping takes the output of one command, feeds it into another command. So piping is always, 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 always 2 commands that are changed. Whereas with redirection, one of the two things is always going to be a pipe. Always. That's an important distinction. One that will help you decide which you need to use, right? Should I be using redirection? Should I be using a pipe? Well, what are you trying to connect together? If you're trying to connect commands, then piping is the way to go. If you're trying to connect files to something, then redirection is definitely the way to go. I think it also should be noted, though, that we can combine, we can mix and match. We can combine stuff together. So, for example, if I wanted to take the output of this and save it into a file, I could very, very much do this. How do we interpret this command? Well, I'm going to take ls dash f. I'm going to type it into Grid, search for names in this output. When I find it, which know that output, I'm then going to take that output and redirect it into a file. Save it into this file. This file doesn't exist, but actually it does exist. I just made it not too long ago. But yeah, we can run that command and then see that, okay, I used append, but there it is. It appended the result of that pipes command into this file. So, very, very possible, very useful to be able to mix and match commands like this when we want. Any questions about grep or any questions about piping commands together? Yes. Oh yeah, I'd be happy to show it again. This is the command that I just did. Yeah, no problem. All right. It's time for another exercise already, actually. This exercise is focused around grep, but I want to do a quick thing with you all before I turn you loose on this exercise. On Canvas, there is a file. If you look at today's date on the calendar, it's called addresses.txt. And the exercise that I want to turn you loose on is using grep to search this list of fake names and addresses to find various things, right? Which means that you need to have access to this file on your computer. You definitely could do it the way that you probably already know how to, which is to, right click and save the file. And I think that's great. Be careful if you do it that way, because remember, the commands that you're running have to be able to access this file. So if you save it in your downloads folder, for example, you may need to CD into your downloads folder so that you can access that file. But I also want to show you another way. What if we can use the command line to download this file? So we absolutely can. I think it's a useful thing to be able to know how to do. So instead of downloading this file, I'm actually going to right-click it, and I'm going to copy the address. I know browsers do things differently, so yours may not look exactly the same as mine, but I'm going to copy the address to this file. And in order to download it on the command line, I'm going to use a command called curl. Curl is a command that we can use to download files onto our machine. We do need to use some flags. One of the flags that I know we need to use is -O, and that is a capital letter O. It is a capital letter O. Lowercase o is a different flag that does something slightly different, and it won't actually work for us. There's another flag that we actually need to use. I found this one out the hard way during the first section. Any of you who have done any kind of web development, web programming, are probably aware of something called SSL certificates. It's a security mechanism, right? And WashU, for whatever reason, does not have theirs set up properly, at least not for this file. Surprise, surprise. But if we use the K flag, that tells it to basically ignore any SSL certificate problems that may arise. So using curl with the OK, I think that's kind of funny that it worked out that way. Couldn't have planned it better if I tried. But that is a capital O. Again, I want to repeat. And then paste. Paste the address of the file that you wish to download. And if all goes well, you should see something that looks like this. It's actually showing you the download, process. It's such a small file that it goes real fast. If it was a big file, you would see, the progress update over time, but it's real tiny, so it goes real fast. And then just to check and make sure everything worked properly, do a cat on addresses.txt, and this is what it should look like. This is what it should look like. If you were able to do that successfully, you're now ready to get started on the exercises. If you want to do it you know, the more common way of clicking on the file and then right click and save as, I don't have a problem with that either. I just wanted to show you that how you can use the command line to download files if you need to. And if you're having problems, if curl didn't work or you just can't figure out how to get access to this file, raise your hand and let me know when I'm walking around, and I'll be happy to come help you out. But now that we've gotten through all of that, I'm going to turn you loose on some grep exercises. Now, I didn't tell you how to do all this stuff. Some of this stuff is going to require you to look at the manual for grep and look at the various options that grep provides to you. I did not explain how to do all of these things. So you're going to have to read the documentation. You have to do some Googling, do some research. I suppose you could ask ChatGPT, but I think you'll develop more skills if you try and do a little digging yourself. So don't be afraid to look at the manual to help you out on how to do some of these things. Some of these will require to use piping. So keep that in the back. Not all of them will, but some of them will require you to pipe multiple commands together. So keep that in the back of your mind as well. I'm going to give you a good 5 to 10 minutes to work on these. Let me know if you had any problems getting that file on your computer as I'm coming around. So, that's oh, yeah. You were stuck. Wait, you need the what is that? Oh, all things here. I did before. Denise, sorry. You want that? Let's go. So I did a tab with a capital E, put it all on string standard. Wait, what is it? Russian tabby was the batch speed just so like it's line 4. It's after dash dash like oh so we should support you're in eight. Okay. Yes. No, okay, it's like music and I get this whole list, yes, and they start stuff. I actually is more to do with the file than any. There's no like in other words the file should have more. But it's showing you the plot. It's very exact, right? It shouldn't stop memory. And it's not letting. So this is an incomplete. Lady from the board. It goes, rep, what am I looking? And you're missing one. Control C is the word. Yeah. No, I should probably get everybody. Everybody gets stuff sometimes. Oh, actually, no. We don't. Look at that. Okay. And then yeah, just entries all. So. I realized I'm complaining now because I was doing thinking only two. If I had that, if you do count, or follow that up with dash capital A, and plus one after. Oh, I think that's hard for him, but you know what the first side. Well, I don't know. There has to. There has to. Only by a. Actually, I'll stop. I'm trying to figure out. That's that mean. So, oh no. Is there any other numbers sense? We do that, I'm not. Oh. Afterward. Yeah, I was just like, so, even if you're just like that. I mean, almost an. Yeah, but yeah, that's. We never got since that's the sense. No, I know it's hard. We could try as. Did include the parentheses. Oh, that's definitely nice. That's a word before. Oh, you guys bug. Maybe it does. So I don't think you need the what's this? Oh, it's. Yeah, but the parentheses. Look. Oh, I put two of them, but I think I have something. Sorry. All right, everyone. I know you may not be done with these yet, but I'm running a little short on time, and I've got one more command I want to show you after this before we wrap up class for today. So I probably won't have time to go through all of these, but I do at least want to show you a couple of them. And if you are stuck on one of them or just want to chat about it sometime, you're welcome to hit me up after class or come to my office hours sometime. I'd be happy to talk to you about any of these. But let's go ahead and start with the first one. The first one wants the complete entries of all the individuals who are from Illinois. So hopefully you started with something like this, where you just ask for it to find all the times that Illinois shows up in the file. And so we can see that there are two entries that had Illinois, but it wanted the name and the phone number and all of the information. So that's where a little bit of extra thought comes into play. We have to think, okay, I can see that fortunately for us, this file is very well formatted, right? Each entry is exactly 4 lines, and the state is always on the very last line. So what I really need, like for Illinois, is to not just get this, but the 3 lines that come before it as well. So search for this Illinois term, but also show me the stuff that leads up to where that Illinois term appears in the file. I know some of you figured this out because I heard you talking about it, but hopefully at least some of you went to the manual pages, or I know the grep manual is quite long, actually, so it would have taken perhaps some time to search through this. Would not blame you at all if you used Google to help you out with this one to give you a push in the right direction. But what we're looking for is actually down here in the section called context line control. So the dash A followed by a number says, give me, so find what I'm searching for, and then give me this many number of lines that appear after that. So that's close to what we're looking for. I think more accurately, we probably want this one. Dash B for the before context says, find what I'm looking for, but also include however many number of lines before the line where you found the search term. So, again, thinking about our format, I want this line, but I also want the 3 lines before it. So to use that flag, we would then use the same command as before, but come up here and use the dash B 3 to say that I also want the 3 lines that come before anything that matches what I'm searching for. And voila, learning that command with that additional flag on there gives us all the lines that match Illinois, but also the three lines immediately preceding it, which contains the full entry for the person with that address. So that was the little trick for that one. I'm actually going to skip ahead to number 3. Count the number of people who are in Kentucky. And actually, let me take a little detour first. There was more than one person who did something like this, where it says grep KY, and you hit return, and this isn't showing me. Well, I accidentally grep requires plus. Where do I want to search for the thing? And I spelled that last word. It's okay. We're all human. We all make mistakes. But what the heck do I do now? I can't, rerun this doesn't look right. It doesn't look normal. Actually, it's waiting. I typed in an incomplete command, so it's waiting for me to finish the command. If I wanted to, I could type in addresses.txt. Oh, actually, I thought I could, but no. Either I typed it wrong, or did I type? I don't know what I did wrong. But anyway, I'm stuck. Grep, help me, please. Right? I'm stuck. This is common. This happens to all of us. It happens to me quite regularly. If you find yourself in this position, Control C is the hotkey that you're looking for to get you out of here. Control C is the get me out of here hotkey. If you're stuck in the middle of a command, Control C will abort whatever you're doing and get you back to a command prompt so that you can start over again. And then you're like, oh yeah, I forgot to put the name of the file. So now I can say say something like this, the way the command is supposed to be read. But this wanted to this information. It was to figure out the count. Clearly, I can see there's 2 here, but I don't want to have to count them. Imagine if there were 200. That would be very annoying. I want the computer to tell me how many there are. That, again, is hopefully another trip to the man page for grep or another little bit of Googling will hopefully help you figure out exactly what we're looking for. But hey, here's a -C flag for count. That seems pretty good. So let's try that same command again with the -C flag. And now it'll happily tell me that there are 2 results that it found. So I know that there are 2 people from Kentucky in this list today. Cool. I don't have time to go through the other ones, but I do want to show you one very, very important command to wrap things up for today. It's another command that you're going to be expected to use on our first in-class assignment. And probably throughout the rest of your programming career. I mean, it kind of depends on what you're doing within the world of programming, but a lot of times I'm not accessing files on my computer. I'm accessing files on a different computer, on a server somewhere. Maybe that's where my research lab stores their data. Maybe that's where my website is hosted. Whatever the case may be, if I want to connect to another computer, the primary way that we do that is using SSH. Those of you who have taken 3300 probably already use SSH a little bit. It's a very common way to access your Amazon EC2 instances, right? That's not what we're going to be using it for in this class, though. We're actually going to connect to a server that WashU provides. It provides it for all students and faculty to use. So the way to get access to that server is to type in your WSO key ID. Don't use mine. That's mine right there. You should. Mine. Who's mine? I don't know my password. You won't be able to log into me. At least I hope you know my password. Use yours. It's the first part of your email address, probably, right? The part that comes after the @ sign is a little bit different than your email address, though. We are SSHing into a computer called shell.cec.woostel.edu. So the back part is almost exactly the same as your email address. Your email address. It's the name of a computer that is on campus. In fact, I think it is right over there in Seaver Hall, which is a building or 2 that way, right? It's where they keep most of the servers. So this is a computer that is not owned by us. This is a computer that is owned by WashU that they provide to us to do academic computing sorts of things. When you run this command, it is going to ask you, whoops, that was a little surprising. Uh-oh, did we crash the computer? Okay, I don't know why it took me 3 times to get it there, but this is what I was hoping it would do. You might have to try a few times as well. We were not crashing. If we are crashing their computer, it's on them to fix. It's going to ask you for your password. So it will, when you start typing in your password, that cursor's not going to move. It'll look like nothing's happening, but I promise you that it is remembering what you typed. So I'm going to type in my password. Oh, I actually typed it in wrong. It's going to tell me I typed it in wrong. So I'll have to type it in again. That cursor's not supposed to move. That's how it works. I know it looks weird. Sometimes it confuses people. It's not working. I'm typing. Nothing's happening. That's how it's supposed to be. I promise you. If you type your password in properly and hit return, then ideally you'll get a screen that looks something like this. And here we are. We've got another command prompt available to us. The big difference now is that this is not my machine that we're on. This is the WashU computer that we're on. Oh, are you getting an SSL thing? Or another error when you do it? Prompting us. Oh yeah, if you may have to type yes as part of the login if it asks you a question. Yeah, I forgot that it does that sometimes. But yeah, if once you type in your password and you get through all that, this is your home directory on the server. All of you actually have this directory. It's been there the whole time, whether you actually use it or not. I've used mine quite a bit. You'll see stuff in here that has to deal with, this class. This is what we're doing today, actually. But these are not on my computer. Again, these are not files on my computer. These are on WashU's server. So any of the commands that I've shown you so far will work here. But you have to, again, remember, these are not just your files. Everybody's files are on here. In fact, I wouldn't recommend that you all do this, but if I take a look, oh, this may not even work. There might be too many. I was going to try and show you all of the people who have home directories on here, and you may have just run a command that's going to take, oh, there it is. Yeah, here we go. These are all people. These are all WashU students and faculty and other people who have accessed this system. Not only that, a fun command that I like to run is a command called who, W-H-O. This shows me who's logged onto this machine right now. So if you've been following along with me, your username's probably on there somewhere, right? In fact, the IT department's probably over there right now being like, dang, why are all these people logged on the server? Holy cow. No, it should be able to handle this kind of thing. It should be able to handle lots of people accessing it at one time, right? But this is a lot more interesting and a lot more realistic of, the kinds of environments when you'll need these commands. Because I'm on another computer. I can't open Excel from here. I can't open Word from here. There's files that I want to manipulate on here. There's commands to do it. I don't have the ability to go into the file explorer and click on stuff. The only way that I have to access these files is via the commands that I type command. So I think that's a really, really big reason why learning the command line is so important. Learning how to play nice with other people's stuff, also so important. If I take a look, if I go back into my directory here and take a look at, the permissions on these files, you'll notice that a lot of them are set to be read-only, so other people can look at them, but they can't touch. And actually, if you try to go into somebody else's home folder, I would imagine for a lot of them, saying, you can't even look at anything. This isn't your stuff. This isn't your folder. You're not allowed to be here. If you want to allow people to come into your folder and poke around at your stuff, you can by changing the permissions using chmod to provide read access to some of those things. But this is what we're going to be using for at least part of our first in-class assignment on Thursday. If you had trouble with this, sometimes students who are maybe in art side and not in McKelvey trouble connecting this way. I don't know if that applies to anybody in this room. There's usually maybe only 1 or 2 people per semester that are affected. But if that does affect you, definitely come talk to me so we can get you sorted sooner than later. If you had any problem at all, SSHE into the server, definitely let me know so that we can get that resolved in time for Thursday. Otherwise, have a nice rest of your day, everybody. I'll see you in class on Thursday. Come on.